name is Eric Pugh, and I'm going to be talking today about big search with big data principles. This conversation, I kind of look at this as a conversation. I hate when I have 80 sets of eyeballs facing me and me looking back at you, but that's how this works. So I'm very open to questions. If it's a little question, I'll answer it. If it's a hard question, I'll say we'll save it for the end. I'm hoping to have a couple of minutes for questions at the end. We'll see. So thank you very much for coming. So what is big search? Well, it's kind of a term of art that I basically came up with. But what I've been working with lately has been really large data sets. And I've been trying to put them into a search engine. And I've been running into some challenges. I've been learning new things. And I wanted to sort of share those lessons with you. I think of search, why is big data here at Lucene Revolution? Why is big data, an entire track? Okay, I'll acknowledge up front because it's a buzzword, right? This is the year of big data, just like last year was the year of cloud computing. I'm anxious to find out what next year will be the year of. But search was the original big data problem, right? When search engines were first built, what were they trying to do? They were trying to make large masses of data digestible. And then Google search kind of came along and wiped out all the other search engines, InfoSeek, AltaVista, all of those. And I kind of feel like the search industry sort of wandered in the wilderness, very much bifurcated into companies and search projects that were all based around intranet search, right? And providing big enterprises with better visibility into the information they had. And while that's interesting, it's not that interesting. I visited a federal agency and looked at their intranet search engine. And you know what the number one query to their search engine was? What is today's lunch menu, right? Okay, so are we going to change the world by having great relevancy tuning and other things so that we know that today's lunch menu, I should show the one that came out today? We're going to make people happy. Search also was very active in e-commerce, right? And so you could say that's where Solr and Lucene, a lot of that came from. But today, search is kind of back as an interesting and exciting area to work in. And a large part of that is because of what we now call big data, is to collect massive amounts of information that we're producing. And my feeling is that search interfaces, whether you call it a search-based application or a search box or whatever, search interfaces are the dominant method for working with big data sets, with big data sets, especially if you're not a data scientist. So when we're building applications that are meant to take advantage of all the results and calculations and analysis that we produce from our big data systems, what do we use to make that accessible to real people? Some sort of search interface. Because real users, want to make a query and get results back very quickly. They don't know ahead of time how to define the question that they want to make. People don't want to write MapReduce jobs. Developers like writing MapReduce jobs. Data scientists like writing MapReduce jobs. But real people, end users, the people who pay our bills, don't want to write those things. They want to make queries. They want to do discovery. They want to work with a search engine. They want to work with Solr, Lucene, the set of technologies. So who am I? I work for OpenSource Connections. We're a Solr Lucene consultancy. Been involved with Solr for a fairly long time. My first patch was in July '07. It eventually became Solr Cell. Other people did that. I also wrote with David Smiley, Apache Solr Enterprise Search Server. And the second edition, which covers the 3.x line of Solr, is published. And so lastly, I'm very into agile software development practices. How many people out there have a Scrum board in their kitchen? Excellent. I see 2 hands, so that's fantastic. As an aside, there's a wonderful website called Scrum for Kids, and it's all about how to use Scrum to organize your family. So if you have lots of small kids, you got lots of things going on, why not apply at home what you do at work? So I'm very big into agile software development. So there's me, my wife, and our best friend who was living with us at the time. I did kind of do a little bit of bait and switch on you guys, because I said big search with big data principles. But honestly, I tried to write a presentation that said, these are the principles of big search. These are the theories. This is how you should do it. And what I realized is that there aren't hard and fast rules. No one's written the big search book, right? Outside of some very specialized niches and industries, this is all still very new to everybody. And everybody's ideas are as good as everybody else's. So I wrote a presentation. I defined 7 principles that I'd taken from a book called Big Data that's coming out on Manning. And I put a presentation together, and it sucked. Because I was like, what does debuggability mean in search? That was a principle of good big data systems. And so I threw out that presentation and said, you know what I really want to do here today? I want to tell you some stories about a project that I'm doing, which is the largest set of data that I've been working with. So I'm going to talk about some of the things that I did in prototyping. I'm going to talk about some of the lessons I learned around application development. And then I'm going to talk about something that I think we often forget, which is sort of operations, maintaining your cluster, making sure that we're not getting 3 a.m. phone calls. I'm going to share those lessons with you, and feel free to ask questions. I think all of these are things, my goal here is that nuggets you will be able to take home and apply to your own Solr project. So I'll do it without the mic. Raise your hands if you can't hear me. Although, as my colleagues know, I have a tendency to yell a lot. So this is not an intro to cloud computing.
For other people to buy.
There's some great sessions coming up about cloud computing. It's also not an intro to SolrCloud. So if you were looking for how do I set up SolrCloud and what's in it and what's new, there are 2 different sessions coming up. I won't take offense if you get up and go check something else out. So here are a couple of my assumptions on this project I was working for. So it was a big federal government client X. And I start out with the theory that what is big data?
It's the thing I want to mention here is metadata also, in many cases, can give you new knowledge.
The data is sitting on disk.
So if you think
it's sitting in a database,
we're going to talk about in a minute,
it's sitting on a system, and you're not really interacting with it, primarily because of the difficulty of working with it, right? A SQL query that takes 3 days to respond and blocks the database, hard to work with. Millions of small files spread all over different servers, very hard to work with. So my working definition of what is big data is less fixated on, do I have 1 million documents, 100 documents? All right, 100 documents is not big data. You can read all that. But 10 million, hundreds of millions, or petabytes of data. It's more focused on the tools and your ability to work with that information and make decisions that your users can look at. So for Client X, I had a limited selection of tools available.
Have a look, looking up
McDonald's. It wasn't an environment where I could go to GitHub and download the newest, coolest thing. I couldn't just go out and grab RabbitMQ as a message queuing platform and yank that and bring that into my environment. Bringing new technologies in had a long time lag, and so I had a limited selection of tools available.
To that, to provide me more context, so that if I want to learn more about this concept,
well, it's because I had that tool available.
But
it was also on an aggressive timeline, right? Didn't have the option of saying, well, let's research this and study
someplace else and type in McDonald's into Google
architecture, and in 6 months we'll start implementation.
More efficient way to get at the data.
Right. This had a sort of real-time need, real-time as in we needed to provide this data to a set of users quickly, and they wanted that information as soon as possible.
Just by looking.
And something that was an interesting wrinkle is all the data. When you did a search
it's
across
a
the data set, it all had to be searched. You couldn't leave any of it lying on the ground. You couldn't use any of the timeout settings in Solr and say, I'll do a search and after 7 seconds, give me back whatever you have. Either none of the data came back or it all had to come back. And there was also a very strong focus on the consistency of the data, right? We loaded, hundreds of millions of documents, and a handful of documents didn't make it in. We had to come up with processes and tools to go figure out. In my Solr cluster, I have hundreds of millions of documents, and I'm missing 5 compared to my original data sources.
You
Which
understand
5 were they? That was a pain.
Numbers are and things like that.
And I was working on Solr 3.x, okay? So a lot of the things I talk about are things that are in 3x. SolrCloud, is advertised, or we're all hoping it's going to solve a lot of problems. I'll try and mention the things I think are no longer relevant with SolrCloud and when 4.0 comes out. But I think a lot of people are going to be using 3.x or are not immediate adopters of some of the new concepts in 4.0. So prototyping. So the project that I had to do with the hundreds of millions of documents was a very straightforward standard search project, right? It's a story we've seen over and over. I have a data store with lots of metadata. I have content files distributed out on sort of network attached storage. I have an ingest pipeline that needs to bring those metadata files in, parse all those content files, and then push that into a set of Solrs. How many people have basically done this at work? Right, very standard story. There's nothing odd or weird about this setup. It's not that we have hundreds of metadata stores. It's not that there's multi-tenancy. Some interesting security wrinkles, but a pretty straightforward story. Okay? So because we were on an aggressive timeline,
that was our primary development platform. And I'd actually never really been a big Unix command line guy. I've been forced to learn to love Bash. We built, I'll just flip back, we built this entire pipeline primarily using Bash because it worked. We had lots of hardware to throw at it, and Bash and Shell is a very fast environment. So these are some of the things that we wrote in Bash.
We knew up front we needed multiple Solrs, that we were going to be distributing the data across a number of different Solrs. And after the first time when we tried to fire up 3 or 4 Solrs by hand, we very quickly realized that we needed some management tools to be able to start and stop Solr. And more importantly, we needed to be able to go out to different servers and say, please start this Solr or stop this Solr. We wrote indexer jobs primarily in Bash as the controlling platform that managed the data flow out of our metadata store and tied it into our content that we had to work with and piped it through that ingest pipeline and called the Java code that put it into Solr. So, and again, we had, we went right off the bat with the scale-wide approach. Our hardware was really big. We could run lots and lots of indexing jobs. So we, wrote up scripts in Bash that allowed us from a central server to start up indexing jobs on multiple different boxes. We did performance monitoring through Bash, right? We called, how many people here are familiar with /admin/mbeans in Solr? Isn't that awesome? Question mark stats equals true, ampersand writer type equals JSON, ampersand key equals
find out about those
docs. And you get back from Solr, how many pending docs do I have?
Even
how
better?
Many documents? It was actually very easy to parse that data with a little bit of wget and a little bit of curl and build some fairly sophisticated monitoring tools that would tell us how many transactions are going right now, how much data is moving in, how many documents are pending. We also looked at what was in the queue, right? We had all this metadata that was getting queued up and spilled out to a file system. How many of those did we need to do? And we'll talk a little bit more about that pipeline process. And then we had content extraction processes that we had to run. And those were primarily
in the
Bash
e-discovery
sort of
space.
control layer, and then some Java code.
Typically, actually, Tika was the content extraction libraries that we used on these documents. And so it was a little bit of Bash and some Java there.
And then our ingestion process, once we had the data in the format that we want and the document in the right format, then we had some Java code that would read those in and throw them into Solr. And so because we were working in this sort of clustered environment with not just a cluster of Solrs, but also multiple indexers, multiple ingesters, other processes running, we had to have some sort of configuration management process, and we used bash and shell to deploy a new version of an index, start up all the processes, give it a label, check it into source control, all those things. So our configuration management was done. Now, I'm sure some of you are looking pretty skeptical at, really? You did all this in bash? I'll acknowledge that we rode the bash train 2 stations too far, right? The team was a very small team. One of the members was just a shell scripting ninja. So you ask him how to do something hard in shell and he figured it out. And so we probably did more of the work in bash and shell than we wanted to. On the other hand, it worked. It was quick. We didn't have to get permissions, and we didn't have to compile anything. A big downside as well, though, was pretty much outside of the guy who was the bash ninja, the rest of us, we did all pair programming for all the production bash code. How many people do pair programming for everything? Yeah, it's not that common. We did it because it's so hard to write good bash code and not to miss a space in the wrong place, and then you spend days debugging. But it worked, and it met our aggressive timeline of let's get something up in a language that everybody knew, and some piping, some Perl, and those things. You can move a lot of information around if you have a high-speed network and a lot of servers. So one of the things, and that is a total eye chart. I'm not actually asking you to look at the details, but we had this, one of the things that we wanted to do was to be very flexible in how we clustered our Solrs. For example, does anybody know what the optimum number of cores is in a single JVM if they're each 10 million documents? Yeah, neither do I. So we had to try, we had to iterate through a fair number of different approaches. So one of the things that we did early on that we discovered was our first architecture, our first pipeline architecture, our first sharding algorithm was very rigid. It said, I have 16 shards, and that's it. And all 16 shards live on a single Solr JVM. That turned out to be a problem, because then we were like,
would number almost 14,000?
Problems. But really, what if I have 4 JVMs, each with 4 shards? Okay, let's try that and see how it worked. What if I need to, instead of 4 JVMs with 4 shards, what if I have 4 separate servers? So this profile property, so we called it profile.properties, and it's just a properties file. We went with properties instead of XML. We started out with XML configuration, but discovered that parsing XML files in bash as a property file was awful. So we went with a very simple profile properties. And if you can read all the property names, they have underscores in them, because that made it very easy for bash to parse them. Dots got evaluated.
Of course, is very important, but also.
And
we did some very basic strategy pattern, right? Everybody familiar with Gang of 4 strategy pattern? To make it easy for us to change our indexing logic. So here is a very simple piece of Java code that creates a mod sharding strategy. So I'm going to take my primary key, I'm going to mod it by a number, 16, 64, whatever, and that will tell me which Solr core to put it on. And it was very easy to write a mod sharding strategy or a date time, right? Pull a date out of the document and do it by that sharding strategy. We just swapped that one little line, index strategy.add document, and off it went to the right place. So this gave us a lot of flexibility, and probably the biggest thing is it kept us from getting too attached to our first assumption of how to do sharding. I think that often happens a lot. People get attached to an approach, the code is rigid, and it's very expensive for you to go try a new approach. And so you come up with reasons why you can't, right? And it's not a can't, it's a I don't want to. So make it very easy for sharding. One of the other things that we discovered is Solr, right? Most people sort of think of Solr as a JVM process with a single Solr with a core in it. We moved to a model where, because we were firing up lots of Solrs and we had lots of slaves and masters, we would go ahead and run our script and say, step 1, go fire up all the Solrs on all the boxes. And that takes an appreciable amount of time. So we used to, initially we did it sequentially. Then we did parallel, no hup ampersand, and we ran them. We actually ran all our Solrs as just a shared username process. There wasn't any service control. We probably should have that, but again, we didn't know how many Solr JVMs we were running, so we weren't going to install one Solr on the box. So we would fire them all up, verify that Solr was up and running. Sometimes you would get a weird collection one generic collection line around, and then we would go out and we would actually create all our cores. So our profile file that I showed you gave us all the data to say, where are all the cores on disk? Where are my data directories on disk? What is the URL? What's the information I need to build the URL to call the create command and say, here is a core I need to create. So if I've got 16 cores, 16 shards, I've got the name of it, called it run2 here, run2_1, run2_2, run2_3, and it would go out there and create them. And if you have a really, really big data set, creating cores can take a fair while it loads that all into memory and off the disk as well. So again, that was a really good thing to parallel, to put as a parallel process, and then come back and look at it again. That process we did initially as all sort of shell scripting. This whole thing was shell scripting. We then started migrating it to using using SolrJ and Java, and taking a lot of advantage of the Java util concurrent libraries to be able to manage these processes. So this is a lesson that we didn't learn quick enough. So we had ginormous old Sun Enterprise, Sunfire, whatever they are, with 256 or 512 gigabytes of RAM and 32, 64 cores, all the hardware you could possibly need. And when we counted up the RAM utilization that we needed, we were like, okay, we can run everything on one box, which is great because then it's very easy to debug. You don't have to deal with lots of IP addresses when you need a distributed query. You just know it's localhost and port 8000 to 8015. But we were not getting the performance that we wanted. Our queries were relatively slow, and we had a lot of standard deviation in the performance. So sometimes they were slow, and sometimes they were very slow. There was big standard deviation in our query performance. So we did not go wide as quickly as we should have. We had all this hardware lying around, and we had to make our processes flexible enough. Our distributed, putting the distributed set of shard names in Solr config, that had to become flexible enough to make it very easy to do. So it took us a little while. But when we distributed our load across 3 separate boxes, even though they were all smaller boxes, our performance problems disappeared, and it became the lightning fast Solr that we all know and love.
So do you have one management box that's firing off these commands, or rsync?
We evolved to that, yeah. Yes. We had Search 9 was the management box. It could have been any of the boxes because we pushed everything to every place in order to have redundancy, but Search 9 was habitually where you would go. You'd run a script, and it would look in the profile file and say, oh, you need me to start up Solrs on Search 1, 2, and 3. I'll go out there and locally run whatever command it was I needed.
Okay, so that was also your canonical property store for configuration as well?
Correct. And that was a problem when we would copy properties to create a new index. You had to actually be very careful about going back through and looking at all the properties because you could easily wipe out an old index or a production index. So yeah, it was so we still have not. We have not licked the configuration management problem. We could solve it by bringing in real ops guys, but then they're not going to want to move as fast as we want to move, and they're going to want to take some of our power away. So they're sort of, it's not perfect. So we did a very simple pipeline. We spooled files out onto a file system and marched them through a bunch of directories, right? This is a very bash Perl way of working. I hadn't really done it this way. I was like, we need to write a big Java app, and it manages this, and it's got these jobs and database tables and everything else. Again, at the prototyping stage, and just trying to understand our data and get a sense of what we had having a directory called db exporting, ready enriching, and using an mv command. I learned that mv in bash is an atomic operation. So two processes would each look to move whatever the newest or oldest file was, and one of them would get it, and the other one would get an error. So the one that got it would move it to the next step in the pipeline and then start doing its work. And the one that errored would go back and try the next one. So we had initially, we had a set of 8 or 10 different indexing boxes, and we SCP'd between the different boxes. Yeah, that was not a long-term solution, right? Worked with a small data set, but as it grew, it got slower. So don't move files was a lesson that we learned. And one of the things that we did then to reduce the need to move files, but still allow lots and lots of indexers work with the same pool of files, is we used NFS for a little while, although that was a single point of failure, and yeah, it didn't work well. And then we moved to a clustered file system called GFS, Global File System. And it worked great when it worked. Basically, every box in the node has access to all the files, and only one of them can change it at a time. Worked great, but you can imagine how much chatter, coordinating, touching, and moving, and doing anything with those files produced, right? And so if two boxes tried to grab the same file and do something with it that was changing it, we would get what they called a fence, which would say, okay, wait, nobody touch the file system, everybody pause, all 8 indexing boxes are now paused until they sort out internally who gets to change things, right? How many people use Zookeeper? We're digging into it. I can't wait for fencing issues with my distributed Zookeepers as well. So we use GFS, but it kind of, and it worked really great when it worked, and it was a disaster when it didn't.
I'm wondering why you're changing files in place instead of writing to a new version.
We did get away from that. But, what would happen? We have lots of spooled out data on the cluster. You know what? Let's go delete some of that because we're running out of space. And let's do that on a Friday afternoon because it's not going to finish until Monday morning. And we have fencing issues, right? So we were running out of disk space, so that was maybe more what we were changing. You're right. We did write to new files. So, HDFS, one of the biggest strengths is it gives us a way of distributing out that file load that is not tied to the OS. Big strength right there, and we're looking forward to adopting HDFS for all our data storage layer.
HDFS and is it Hadoop?
Yes, yeah, Hadoop distributed file system. So, because of the pains that we had with this clustered data system. Zookeeper also was fantastic. So what we're doing now is instead of maintaining state on the file system, we're just writing all the files out to a single location, and we are marching them through a pipeline just like that, but in Zookeeper. Zookeeper's core concept is sort of a directory structure, right? You've got nodes that have subnodes, and moving things between them is a completely atomic and robust solution, as long as you don't have much data in it, like less than a megabyte total or per node, I'm not totally sure. But we're now using Zookeeper for this state management. So, and that is proving to be fantastic. So don't move files. One of the things that we ran into is we had to get much better at testing our changes, right? We would make a change like we went from stemming all our fields to unstemming. No stemming at all. It's a business requirement. You win some, you lose some. And our index exploded in size. And our performance went right in the crapper. And we tested that by going to production and having our users prove that the performance went right in the crapper. We learned from that. And so we took some time in JVM tuning. My biggest takeaway on JVM tuning is don't do it. Let Java do what it wants and leave lots of OS RAM. That's my biggest takeaway. You have to have a really good reason why you're doing things. And it's very easy to think that you're doing the right thing and go completely the wrong way. The first guy who did the JVM tuning and gave us this great set of parameters with all these great backup data was totally the wrong way. We discovered later. But you do get to learn a lot about using JConsole, Visual VM. This is useful. This is kind of what you're hoping to see, though, out of your JVM, right? You want a nice, and that's over a short time range, but a nice sawtooth pattern, right, across all your servers. And if you're not seeing that, think about going wider, because that might solve the problem. How many people here are familiar with Solr Meter? Yeah, come on. Hold up your hand if you're a committer on Solr Meter. Yeah, and active. So Solr Meter is my favorite secret weapon of Solr. Solr Meter is a load testing tool designed for Solr. Load testing for Solr requires two things to be happening: updates as well as queries happening at the same time. With Solr Meter, you get some great visibility into all the query caches, all the caches, performance error messages. You can set different load levels. You can have different patterns. And it's very easy to use. Do I love that it's a Java Swing app? No, but it does make some pretty charts. So we very quickly, after that first production disaster, we wrote some scripts that would parse out of the log a previous day's worth of work and feed that into Solr Meter. Solr Meter has some built-in tools for building queries. That's kind of what the default is. But you can also just give it a text file of, these are all the queries that I want you to run. And so we would put that in there. Get to know and love Solr Meter, because it's the fastest way to tell, did sharding wider work? Did changing my schema configuration work? It's a fantastic product. So application development. What are some of the things that you want to think about as you're building your applications when you have massive Solr data sets? And these are sort of things that are, where you're not setting up one application, one Solr, another application, another Solr. You're trying to share some of those Solr resources, and therefore your data sets are going to be bigger. Well, a quick tip or a quick feature is the CSV Export, CSV Import process, right? If you're building an application and you need to grab some data, often developers have a tendency to work with really, really small data sets, because it's a pain to go get millions of records out of Solr. And you don't want to rerun the indexing process from scratch with all of the, I need Zookeeper, and I got Hadoop, and I've got shell scripts, and I've got all of that going on. I love that I can quickly, and this script just shows you, grab 500,000 rows out of Solr as a CSV file, write it out to the file system, and pipe it right back in. I've never actually been able to get like a pipe in Unix to do this. I've tried a couple of times, that never quite worked. But it's really easy to rip out all the data and stick it back in. There is the caveat, you have to store all your data, right? So if you are talking about big data principles, one of the things is in the big data world, you always store the raw form of all the data versus the compiled form. I kind of think of that in the Solr world as we have the original text stored in our indexes. So that works up to a certain point, of course. Using Solr as a key value store in your applications. If you're doing long processes when you're building these indexing processes or applications. In the project that we were working on, we were getting thousands of queries per second without using Solr 4's real-time Git, which might be on 3x. 4, okay. So we were getting thousands of queries per second. We had a couple of distributed ones with master-slave. Updates would go into the master. And it was a really easy way to store sort of intermediate data formats or things that we were doing over and over and over again, right? You don't want to do the same task multiple times. If I've got in my raw, if my documents are very sort of flattened out, I might do content extraction and extract the same piece of content for 1,000 documents. I don't want to be doing that constantly. We use Tika. It would take like 2 seconds per document. You can imagine how long that would take and how many ingesters we'd have to run. So we set up Solr as a key value data store where the index pipeline would read from that and pull out that data. If it didn't have the data, then it would go and do whatever work it needed to do before throwing them into Solr. That was the slide that was supposed to be in that order. So I am very excited to see how fast the Git feature works, because it doesn't deal with commits. It just, when you do an update to Solr, it will be immediately accessible, and it doesn't have to go build a whole query to get that data. Probably a big thing is you're going to end up defining the schema out to your applications. All right. This happens all the time in the Rails world, right? People use Sunspot or whatever. They're building their Solr schemas off their active record objects. The schema is already mastered outside of Solr. Today, we use dynamic fields to be able to support that. So it's not that there isn't any kind of schema, it's that the applications have to understand that schema. And so in my little example, if you think of in my little query there, if you think of a data store that is collecting information from multiple municipal records, right? Information about how good the streetlights work, information about plumbing or sewers or whatever. You could stand up a single Solr and define a set of rules, your dynamic fields, and then push the data in from the applications. And it's up to the applications to understand enough about Solr so that if there's a null field, it deals with it cleanly, right? And if you modify the schema, the application understands that I had version 1 of this object, I have version 2 of this object. Both of them may be living in Solr at the same time, and when I get that data back, what do I do? So I find, though, that this reduces a lot of work in the search people have to do. It means that you have to learn more about your application developers and what they're trying to do, because it's not all just sitting there in schema.xml. But as people give you changes fast and furious, it's the best way to deal with that. So don't do expensive things in Solr, right? I love Solr Cell or Tika, right? That's kind of what got me into the Solr community way back, was trying to do that, right? I want to feed PDFs to Solr and get back text. It's fantastic when it works. The update request processor chain allows you to do some really, really cool things with your text as you're coming in. And it has a great place to go. Solr has great configuration values, so I can pass in my options. I just do it in solrconfig.xml. Wonderful. Don't do it, because you only have 1, 2, 3, 4, 100 Solr servers, but you probably have 10x indexing boxes, other boxes available. Solr is getting those documents into Solr, updating those documents into Solr is your bottleneck, because Solr has to do that as well as serve whatever queries you have. So despite how wonderful those things are, especially for prototyping or smaller data sets, don't use them if you're trying to go to sort of big data scale. It'll also save you a world of hurt with weird memory issues and everything else. So, anyone working with Aggro? Excellent couple. So Aggro is yet another product of Nutch, Lucene, Hadoop ecosystem. Aggro is a binary serialization platform like Thrift or Protobuf or some of those others, but it's also like Smart XML. The schema for my object is stored inside my Aggro file. And so I can have an Aggro file that I read in, and my application gets the schema. So if I have 10 different versions, I've compiled, built Aggro files, serialized data out in 10 different types of fields, etc. I have a schema that lets me resolve those intelligently and move them backwards and forwards. And Aggro is designed to be compact and really fast to be read. So, for example, say you got a 2 gigabyte Aggro file, which is pretty easy just to stream out and build. And now you want to do processing, you want to go through it. It's got markers in there that you can say, okay, we'll split this Aggro file up into 20 segments, and I'll run 20 different jobs over that Aggro file. So Aggro is really exciting, and we used it to serialize out the output of anything that was expensive in the ingest pipeline. So especially, not so much when we were doing a full index, let me start from scratch and build everything, but when we were doing sort of updates, streaming updates as they were coming in, we'd periodically have an expensive thing to do. And so we would write that out on the file system to an Aggro file, or stack them up until it wrote them all out. And then periodically we had another process on another set of boxes go back and read through those data files and throw it all back into that Solr key value cache. And because Aggro had the schema inside, we could have multiple different ingest pipelines that occasionally did the same basic work, but different versions, and you could throw that data out, and you didn't have the Java binary, Java serialization problems or anything like that. So it worked really well to take those expensive operations and in the background feed them back into our Solr key value cache. So another one, don't use the Java binary format unless you know that all your Solrs are the same version. So, anyone tried to write a client that speaks both versions of Solr and uses the binaries, you're hunting down a million different libraries. You could try Reflection. It's a pain. I'd love to see Aggro used as the data transfer format for Solr. Turns out to be harder than it looked, though.
So you're talking about replication?
So replication, I'm thinking more from a client perspective. Replication, you constantly hit that problem, though, right? You have to update one and then update the other, and I think that that's a harder problem to solve because replication is moving those binary segment files around, which you want to keep as binary segment files, not as Aggro files. I guess you could, but but really more from a client perspective and moving data between different locations. If I look at this, our Solr key value cache got huge. And cache makes it sound transient. Should be key value data store, I guess. It got huge. And the work to rebuild it would be just weeks and weeks and weeks of processing to rebuild it. And it's in an older version of Solr. We want to go to Solr 4. So our pipeline, right, which one do we use? So we found that we would sort of commit to one, the production servers or whatever, so we use the binary format for them for whatever performance, but the rest we would use JSON or XML or something else. So a couple things about maintaining your cluster, and I know I'm running out of time. A colleague of mine showed this, David Lyle. There is an awesome command, the index upgrader, that allows you to upgrade your Solr indexes. That is way faster than rebuilding things if you're migrating between different versions of Solr or you're working with different versions of Solr. Did everybody already know about this command? Okay, good, because I didn't either until recently. So, works fantastic. We took a 3.4 to a 4.0 and started playing with SolrCloud. I don't believe it's backwards compatible. You can't go down, but you can definitely go up. Make your indexing processes easy and quick, right? Dollar Tree is a crappy little store with crappy shelves and crappy merchandise that never has everything. And you go in looking for something, toothpaste, it's never there. The space shuttle costed $500 million to launch it. Everybody had to be on board. You had to plan it to the nth degree. A lot of indexing approaches, building an index, are like that, right? It's either a cross your fingers and pray that it all works, or it's we need DevOps and systems admin and procure extra hardware, and it's going to take us 3 weeks to build the entire index, right? One of our clients, their search index, it takes 3 weeks for them to build. Like, well, what if it goes down? Yeah, we're in real trouble. We have to take backups and do all these other things, right? If you can build your index fairly quickly, and obviously it depends on what your definition of fairly quickly is, you could be a lot more aggressive. You could take more chances because your downtimes are going to be less. Near real-time versus big data. So Solr 4 has what I consider two competing features. Soft commits are designed to get documents there as quick as possible, right? And make them visible to all of us. All the leader elections, sharding, collections is designed for us to scale crazy big, right? And I often find, I have sort of two variations on this graphic, is that if I have less than 10 million documents in my index, I can do near real time easily, right? No sweat, right? Even without soft commits and things, I can do it very quickly. If I have more than 100 million documents, I can make a case to people that, yeah, we get updates once a night, right? It's not going to show up in 5 minutes. You have to have standing queries. I can make an argument. But if you're in between those, people want the scalability of a big data system, but they want the real time of a much smaller system. And that is a hard place to be. Hopefully Solr 4 does solve all these things. There's another version of the same thing. So, something that saved our bacon was the Grim Reaper. So this is HAL 9000, Space Odyssey, right? So unfortunately they didn't have a kill switch on him when he started misbehaving. The more servers you're running, the more Solrs you're running, the more indexing processes you have, something will misbehave. Something will lock, something will block, something will just go to a crawl and you don't know why. But you have to solve the problem because you have real users and you have problems to solve. So we had a shell script called the Grim Reaper, and we had a couple processes that would look at our Solr logs as well as some other metrics and write them out to a file. And periodically the Grim Reaper would go through and say, okay, are any of you running slowly, too slow? And it would just go and kill them and restart it. Obviously, we had a load balancer in front. We would disable it so it would fall out of the pool. Existing queries would all complete, bring it back up. But having that Grim Reaper really saved our bacon. And now he fires off once every couple of weeks. He used to fire a lot, like 10 times a day when we were having problems. But once we scaled better, now he fires periodically and seems to work. And because it happens so rarely, I don't really care that the Solr ran slow for some reason. It's not worth trying to solve it because the problem got solved. I think of it as akin to Google's data centers with the container load of servers, and they put it in, and then once 20% of the servers have all died, they pull it back out and send it back to the factory to fix it. It's not worth troubleshooting them if you have a good Band-Aid. And then lastly, the bad data creeps into your index and wipes everything else out, right? One of the things that we did, and we've been really happy with it, is we have an off-site Solr in another data center, kind of a long way away, but ready to go. And he has delayed replication. He replicates every 3 days. We're in an environment where there's not really anybody in the office on weekends. So we were worried that on Friday night something bad would happen and it would replicate everywhere and nobody would know until Monday, right? And you would have lost your indexes and everything else. So we have a guy who runs every 3 days and just grabs the latest and waits. And so worst comes to worst, we only have to make up 3 days worth of data. We only have to replay back in 3 days worth of data. So, and you're going to hear from your users, hey, everything disappeared, or something went wrong, nothing is working. I've seen replication all of a sudden quit working, and that index was hosed and never really figured out why it was hosed. So having this, we've also done it using rsync just to take snapshots and put them somewhere else. But this way it's up, it's running, you can do queries against it, test it for sort of real. And then I love the enable disable feature, health check file, which in 4.0 got moved inside of a request handler. And there's a little demo button, disable ping, enable ping. Does everybody know that it's very easy to have a button in Solr that says take this Solr out of your load balancing pool? So it's great when you're starting up Solrs, creating cores, you just disable it. Load balancer's like, okay, ping's giving me back a 500. Click enable or call the web command, and now it's back in. I think that's about time. I think the only other things I wanted to say is think about provisioning. We're writing Chef and Puppet in Bash. We know it's a bad idea, but we're like a good chunk of the way. But we do have plans to bring in Puppet, I believe. That's going to make our ability to deploy new boxes that do different jobs much better. And lastly, we have seen that we started out with segmented environments, a small dev environment, small integration, small prod, and we added more boxes to prod. And what we've seen is that anytime we're doing anything at all remotely complex in an integration mode or a development mode, guess what? We run them all in production. So if you're thinking about big data, don't think about separate environments. Think about a big pool of servers all connected together with great network, lots of fast disk access, and just repurpose those servers for different jobs. So in this particular picture, I've got all my servers in one pool. I'm using one for development. I'm using most of them for a load testing scenario, and I've got 6 for production. If I've got good provisioning processes, if I get a whole bunch of inbound traffic, I can wind up some of those load testing boxes very quickly and redeploy them as search boxes to meet my end user load. So, and then lastly, failover. In the big data world, you don't really have failover. You have clusters where you anticipate something will die. So, thank you very much.